Let's do the quiz. Shaking it up a little bit. What's that? Let's see, recording. Full screen. You got it right? No. So tell me how to start. Well, I need to go slower, man. I need to be even easier. What's this voltage? What's this voltage? What's this voltage? And what's this current? And what's that equal to? ID, which is KP. Should we put numbers in? Save time. 120 microamps per volt squared over 2 times 10 over 2 times VGS minus 0.8 squared. And would everybody be okay if I wrote this as 300 micro? Too many steps skipped there. Yay or nay? So would everybody okay if I wrote 5 minus 2 VGS equals 20K times 300 micro is 6,000 milli, which is 6 times VGS minus 0.8 squared. The pain is high. 5 minus 2 VGS equals 6 times VGS squared minus 1.6 VGS plus 0.64. 5 minus 2 VGS equals 6 VGS squared minus 9.6 VGS plus 3.6 plus 0.24, so it's 3.84. Does everybody agree with that? Does it bother anybody? I'm not relying on my calculator, but I'm using my brain instead. It's bad, huh? So now I'm going to move these over, and I get 0 is equal to 6 VGS squared minus 7.6 VGS minus 1.16. This was a very unreasonable problem. Now what? When I was in school, even back then, we had calculators that could do solving the roots. Of course, they cost about $500, but so opposite b plus or minus squared of b squared. Let's go ahead and cheat. B squared is 7.6 squared, 57.76. Minus 4 times A is 24 times C, so 24 times 1.16 equals, and then it's minus 4AC, so that'll be plus 27.84 divided by 12. Yay or nay? And then we have 27.84 plus 57.76 equals square root 9.252. So we get 7.6 plus or minus 9.252 all over 12. Which root is it going to be and why? Yeah, I don't want the negative because why? negative VGS, be less than the threshold. So I'm going to put plus 7.6 equals divide by 12, shoot, divide by 2, divide by 6, lazy, 1.4 volts. Okay, but that's not what it asks for. It asks for the current flowing. So I write I equals 5 minus 2.8 over 20K. Where did I get the 2.8 from? 2 VGS right here. That's that voltage. So 5 minus 2 VGS. And so that would be 2.2 over 20K, which is, I don't trust any of you, so I got to do it myself. Oops, I don't like that. 1.1 times 10 to the minus 4. How do I get engineering notation on this $9 calculator? It's probably $5 now. Let me see. I know it's 11 milliamps, but I want to put my calculator in the right mode. Damn, my vision's going. It's mode, and then engineering notation is, which one? Scientific, normal. Holy crap, I can't see worth a damn. Shift. All right, I can't see where to put it in. I see scientific, but I don't see engineering. Fix. Norm. All right, 11 milli. And because I have plenty of time, because I got 15 whole minutes, and I've been doing it in about 7 minutes, half the time, I'm going to double check. So if I have 11 milliamps, that would be 2.2 volts across 20K, plus 1.4 plus 1.4. Yeah! What's that?
Yeah, 110 micro.
Oh, did I do this? See, that's why I wanted to put it in wrong. 110 micro. Yeah, I got 4 instead of 5.
Calculator.
Was that problem tough? Did the homework prepare you to do this problem? If you did the homework, it prepared you. I mean, come on. Would it be evil? Did everybody get it right? You did? You got 0 current?
I got 0. And I just was playing for super now.
Really? So you're saying it was so easy I should have given you a harder quiz? I'm sorry I failed you as a professor. Would it be unreasonable to give you something like this again on Tuesday? I'm just going to keep giving it to you, and then you're going to be like, I don't know why I failed his class. He kept giving me the same stuff, and he expected me to learn it. What's wrong with him?
So, real quickly, since the NMOS is the same size, that means that they have the same current going through, and that's how you know the VGS is going to be the same. But if they weren't the same size, then you can still do it. It's just a little more.
Yeah, just be VGS1 plus VGS2.
Right, okay.
Questions? Everybody knows this. They can do it.
Yeah.
You can?
Give it to me again.
No, because then if you messed it, I'd start crying. You're like, hey, what am I doing with my life? All right. Let's go. Any other questions on homework or anything? No? No, none whatsoever? It's going to go well. Oh, do we need to meet? Do we need a study session? Do we need a study session?
You know what, sorry guys, I actually asked them the last class session if it was possible to maybe like meet an extra class just for like questions that like are kind of like, you know, fragmented in my head. But
Like work problems? Do you want to do that? When?
Tonight.
No,
It's fine with me.
unfortunately, I have 3 midterms next week, so it's really like.
Well, we can wait a week too. You wanna wait
But
till
then-
right before the
but then your
final, the
midterm's the
midterm?
week after.
Yeah, we can
So
wait
that
till.
weekend before?
But I don't want you to say that, hey, you went in this class, I didn't know what the hell was going on, he was very unreasonable. I don't,
The team's hired.
all right, well, we can meet next weekend if that's what you prefer. If you have all the, you guys tell me. I'm here to help. Is that good? Yeah, all right, right before the final, or the midterm. All right, so let's review what we went over last time. So does everybody understand that when we do the midterm exam, it's going to be questions like what we had on this quiz, last quiz, do some quadratics. You got to learn that, and it's not hard. Once you set it up, it's a 9th grade math problem. Does everybody follow that? I'm not trying to trick you. Okay, so let's go. Of course, you might feel differently. Let's review CAS codes. Here's a CAS code. And what was the, tell me again, what was the purpose of CAS coding? Yeah, output resistance. Make the curve flatter. Okay, so I'm going to ask really simple questions here just to make sure everybody follows. How'd you like having the quiz at the beginning and then working it? You don't like it?
I need to like get into the,
Brother, I can't please everybody, anybody, man. Okay, what's this voltage? What's the voltage between here and here? Wait, between here, I put my meter right here and here. You guys are killing me. What's the potential difference between this node and this node? It's 0, right? There's a wire connecting them. They're the same potentials. Everybody see that? Okay, so what is the potential here relative to ground? 2 VGS. And then what's this potential then? Assuming everything's in saturation. Okay? And then what's this potential? VGS. Tell me how I could make it so this potential is not VGS. No, just real simple. How would I make this potential? I'm assuming that my current sink is sinking a current, right? Does everybody follow? How do I make it so that's not VGS? No, I only ask easy questions, super easy questions. How do I make it so there's no potential here? Well, I just connect this to ground, right? So if I connect this to ground, there's no potential across the current sink. So it goes to ground. I'm assuming when I say VGS here that I've got a voltage here which is greater than the minimum voltage across there, which is VDS sat, plus VGS. So I'm assuming that the voltage for both of these to be in saturation is VDS sat plus VGS. Yes?
So, no, and I think it was 2 videos ago, you have the current, you need a PMOS on top, because in order to be...
Here?
I'm sorry, no, I'm thinking about the circuit so that I understand this one. You go back and you have it so it's not dependent on the VDD, right? So you want to make them...
Yeah, you could put a beta multiplier, BMR, go to a PMOS. So this is V bias P. Then go to 2 NMOS, and then mirror those out.
Right, so what you do is then...
That's the same thing.
When the PMOS turns on, right, then it has a current. And
Yeah.
so therefore the NMOS then is it runs off of that current. So it's dependent on
Yeah,
the
it's
current,
this.
right?
This is this.
Right, so the only thing is when you went later on, you did a switch, right? You did a switch for the startup.
Yeah, but that's in the BMR. That's independent of this stuff.
You did it specifically to that. You did a switch because at the beginning there's like a little, there's like a gap where it doesn't.
Well, wait. forget all that. We're assuming the BMR is operating normally. We're assuming that we are generating a bias voltage, and we're assuming that we're biasing a current. Now we're talking about how do we increase the output resistance of the current mirror with all this working properly. It's started up, we're biasing a current source, it's independent of VDD, but now how do I increase the output resistance? Does that make sense?
Yeah, it does. The question that I was leading to was, how does the current actually run through there? Because the current can't run it can't run left, right? It just goes straight down, and then on the right-hand side.
Yeah, you need to have some potential here, like a resistor. Remember your homework? You need to have something that you can pull current from. That's what I said. If I ground this, it doesn't work. No current flows. I need to have something to pull. And NMOS only sinks current. It's like the drain in your sink, all right? PMOS only sources current. It's like your faucet. Does everybody follow that? You follow that, Eric?
You asked, I asked you what to do.
I know, that's why I'm asking you. All right, so everybody,
Always, right? It's
what's
always
that?
like- it's
Yeah, always.
So the PMOS is just always gonna be that current,
Yeah,
the
for
source.
current sources and current sinks.
So if the PMOS doesn't turn on, you don't have any current
Right.
whatsoever, and so therefore the NMOS is gonna be dependent on the VDD.
Yeah.
Right.
So, but I mean, that's not the point of this. The point of this is how do I increase the output resistance
I
here?
just wanted to clarify.
Okay.
That's all. That way I can,
Does everybody understand if I give you a quiz question, I say sketch the basic CAS Code current mirror, label the voltages, what's the minimum voltage I need on the output here for the circuit to operate in saturation? Does everybody understand this?
but that should be VSG, right? Oh, it's the one on the bottom.
Yeah, it's
Okay.
this voltage, the voltage across here, which is VGS. Does everybody agree with that? Okay, plus the minimum voltage here. And then at the end last time I said, hey, I don't want VGS here. I want to have VDS sat, so I'm going to redesign this for wide swing so that I can get 2 VDS sat across this. Does everybody follow that?
So where do we put R out? What is R?
That's how flat the curve is. Remember when I plot?
Slope? Curve?
Yeah, 1 over the slope is R out. Remember the very first lecture we said, oh, we do IV plots. This is a resistance, 1 over the resistance. This is a voltage, this is a current. Remember? That was way back 2 months ago. What? Is that right?
I'm sorry, yeah.
Okay. Any other questions? Okay, so I'm going to review because I'm scared now. Got me scared. Now, I'm going to give you something, and I don't want you to shut your brains off. I want you to leave them on. I always shut my brains off when you talk, dude.
So that's the same as the current source.
You're killing me. What is this circuit? That's why I say don't shut your brains off. It's the quiz, right?
But is there a difference that you put the current source?
Yeah, if I put the current source, I'm more independent of VDD. If I don't, I have VDD here, it's going to change the current. So what was the current flowing in here? Is everybody cool with that? And then these were 1.4. Who cares? They're 1.4. So let's write them. Is everybody cool? So I'm going to make a CAS Code current mirror now. What's the potential here to here? Yes, I just, hey, man. So I'm going to leave the circuit just like this, and I got 1.4 volts there. What's this voltage? It's exactly from the quiz, right? Okay, now I don't connect anything there. What is that voltage and why? You're killing me. I have nothing connected there. There's nothing connected. What's the voltage there and why? Okay, I have nothing going in my sink. There's no water going down the drain. What's the pressure on that drain? 0. There's no water flowing down here. There's nothing connected. It's 0. Right? I plot that in my curve and I say, hey, water, I, versus pressure, Vx. And when I'm at 0, I'm right here. I have no water flowing because I didn't have anything connected. Where, you say if there's a water flowing, where does that water come from? Where's the water going to come from with nothing connected there? I know what you're thinking. He doesn't know what the hell he's talking about. All right, so here's what I'm going to do. I'm going to connect this up to 5 volts. And now I'm going to say sketch on the curve where you're at and how much water flows. Neglect output resistance. So it's what is it? How much current flows through here? It's a damn current mirror. It better be if it's operating in saturation. That's the whole point. So then I go over here to 5 volts. I go up, and I'm at 110 micro. Does everybody follow? And then I say, hey, dude, I don't like that. What I'm going to do instead is I'm going to take this 5 volts, and I'm going to drop it down to 0 volts, and I'm going to plot what the current looks like. When I'm at 4 volts, how much current flows? 110. In fact, I'm going to get a curve that looks like this. Here is going to be where it's nice and flat. This voltage here will be greater than this voltage, which is 1.4, plus the minimum voltage I have here to keep this in saturation, which I am learning, so let me write it down. So I need at least 0.6 volts. So once I get to 2 volts, I'm going to see this guy start to go into triode because I don't have enough current. I don't have enough voltage or pressure to move him into saturation. And I keep reducing the voltage. And you know what? As I shut off my valve, as I reduce the pressure of the water flowing in the sink, what happens to the pressure? It drops to 0. I have to have a minimum amount of pressure, and I have to have a source of current. Does everybody follow that?
Did you describe right before 2 volts? It has that, like it's going into triode, right?
Yeah, so right here's where this guy triodes.
Uh-huh.
We can sim this, easy. I'm not going to, but we could. You could sim it on your own. It takes 2 seconds. Everybody follow. Does everybody understand that when we say, oh, we need 1.4, it's assuming we got a pressure here, and that the pressure is high enough to keep these in saturation. That makes sense? Questions? I don't want to move on if this isn't clear. There's no magic here. This is a real circuit. Okay, so now I want to make it, I'm going to modify this. This is the basic CAS Code. You sure you don't like PowerPoint? I think it's so easy to just point to things. I want to modify this so I get something like this. So I don't go have this minimum, but instead I have a voltage here of 2 VDS sat. I want to modify the basic topology. Would it be unreasonable quiz to say, hey, find all, especially if I gave this part of the circuit, which was the same quiz as today, and I put 3 volts here and I said, find all the voltages and currents in the circuit. It's just the same thing, and then you just go over here and go 1.4, 1.4, 2.8, and then if there's 3 volts here, you go 110 micro. Any questions on this? Yes?
So why the first going to
Triode.
I don't have enough-
The other one.
Because
GS?
no, what happens is I don't have enough pressure here, right? So this voltage stays at 2.8. So as I start to decrease this, the voltage drop here keeps this up, keeps this above what it's needed to keep this in triode. So this voltage here keeps this guy turned on, so it becomes a resistor. So when this starts to triode, you think of this as nothing more than a resistor going down. And only when the pressure here increases beyond what can happen. Remember your problem in the homework where you said what's the maximum resistor? As you drop this voltage then, you're going to reach the point where this resistor is not big enough to allow the 110 microamps, or it's too big and doesn't allow the 10 microamps, then this will triode. You know what you can do? You can go simulate this and you can go, okay, what if I do this? What if I do this? What if I do this? Till you know it backwards and forwards. Okay, don't take my word for it. I can sit here and say it all day, but until you actually go and try it yourself, you're going to keep thinking he's a liar and he's not telling me the truth. All right.
I got a trivial question real quick. For the basic CAS code,
Yeah.
the V min has to be 2 VGS minus V threshold, right?
The V min, it's super easy, man.
2 VDS sat plus V threshold, right?
2 VDS sat plus V threshold, yes.
Or 2 VGS minus.
Yeah, let's write it out so that it's nice and easy.
You can just write it either way. You can write 2 VDS sat plus V threshold.
Let's
or 2
write it.
VGS minus.
Would everybody be okay if I wrote 2 VGS? Just to be different. Is this any different than what we've been looking at? Everybody understand it's exactly the same. Does everybody understand that both of these are VGS? Does everybody understand this voltage is VGS? So if this is the way I've got this drawn, I got to have at least VGS, and that is, what is it?
Oh, yeah.
You just reset it.
VDS yeah, plus V threshold. There you go.
Just out of curiosity, when you took 320, did you cover this? What?
Yeah.
All right. Okay, because if you said no, I'd be like, oh my. All right. And then what's the minimum voltage I need across here? But wait, why do I have to have VGS across this and only VDS sat across this? Because the way the biasing is, I've got 2 VGS here. Does everybody follow that? I'm going to modify this on the next page. So then I go, all right, let's look. I've got VDS sat, so this voltage has to be greater than VDS sat plus VGS. But wait, if it goes above that, say it goes to 5 volts, how does this voltage here change? Say this goes to 5 volts. How does this voltage here change? It doesn't. It just changes the voltage across this device. And as I change this voltage starts to change. As I lower it until this guy triodes, as we just discussed, and I keep lowering it, then eventually this will triode because I don't have enough pressure to keep this at VGS. And my current will drop drastically. Okay, but I don't want this to be at VGS, so I'm going to make a wide swing mirror. Any questions?
So just real quickly, what my question was trivial. At the top right, we have VDS sat plus VGS.
Yep.
That's equal to 2 VDS plus V threshold, and it's also equal to 2 VGS minus V threshold. I was just wondering if either one of those. It is. It's just,
I mean, I can write it in lots of different
right.
ways.
I was just wondering if there's one, like 2 VDS plus V threshold.
I like this better,
Okay, cool. That's
Yeah.
good.
but I mean,
That's fine. Yeah.
as long as
That's
it's
okay.
concise and clear. Why don't I real quick, before I move on to the wide swing, rederive the output resistance one more time? Let's use sky blue for that, because it's a nice day today. It's a nice day for a walk in the park. Okay, so tell me, what's the AC voltage here? What's the AC voltage here? So would everybody be okay if I said that VGS 1, if this is M1, is equal to 0? So would everybody be okay if I wrote the following? So where does this point correspond to in the schematic? Yeah. And everybody agrees it's AC ground? And so if I apply a test voltage, now remember, if I actually do this in a real circuit, and tell me if I do this in a real circuit, say here's my output of my CAS code, and I go, oh, I got a homework problem, it's due on Tuesday, I'm going to determine the output resistance, so I'm going to connect an AC voltage here called V test to the drain. What did I just do wrong? I want to minimize the time I put in the 420 homework. Well, tell me, I mean, this is a real circuit. What did I do wrong? Or I go to test this. What's wrong? Doing this in the sim. It needs a bias. It needs to have a voltage above the VGS plus VS sat. Does everybody agree? So I need to have it biased up. So when I talk AC, I assume the DC's there and everything's biased in saturation. But I don't go to do my AC circuit and remove the DC biasing because it don't work. I'm moving up on a curve, so I have to add a DC here. I'm assuming that's there. If you go look at the examples in the book, I don't determine the small signal output resistance with AC without a DC in series to bias it up. Just like GM. When I draw the GM, I assume it's biased at some voltage, 1.4 volts in the example I gave. Okay. So if I do that and I call this I test, the first trick was noticing this was VGS. What was the second trick? Okay, but that's not the trick.
I'm not
That's
sure what the tricks is. The gate to source, that's going to be VGS 2.
what?
The voltage and the node is EXRI.
Yes. Or IT times R1 at that voltage.
Yeah, the thing to notice is what current comes in, goes in, has to come out.
Yep.
That's the trick. You don't get that, you feel pain. And you waste time. Man, that quiz was long. Man, that test was long. So what's this voltage? And what is that equal to? 0 minus IT R out N is equal to VGS2. So I can write, how about I write it out? 0 minus Does everybody agree with that? 0 minus V source, 0 minus V source is equal to VGS, because what is 0? Is everybody cool with that?
VGS is equal minus IT.
Yeah. Here, we'll write it nice and neat here. Don't want you complaining. Man, that dude's sloppy. I know how that feels, believe me. Been grading those homeworks. I'm like, oh, man. Why should I make my bed? It's just going to be slept in again tonight. All right.
IT is equal to GM VGS 2.
So tell me what to do.
IT is equal to.
IT. How about let's do it. We did the top node last time. Let's do the bottom node. So let's do the KCL here. Going in is GMVGS2 plus V test minus I test R out in, all over R out in. What does this voltage correspond to? This is just this voltage, V test, minus this voltage. And that's equal to, okay, because I remember, if I don't remember that's the current leaving, I'm going to inflict pain on myself. If I do remember, then it's easy. Don't start talking like me. People don't like that. Did you change the oil like I said? No, I forgot. Are you trying to inflict pain on me? All right. Should we proceed? Or do you remember what the answer is?
Yeah. GM
So what is VGS2? Put that in there.
Minus IG R.
Yay. Any questions? No? Yes?
In this case, R out is going to be the same both.
Yeah, same size transistors, I'm assuming.
If it's not, we have to distinguish it.
Yeah, you do it separately. It'd be one is R out 1 and the other's R out 2. It's easy, we just put in the right values. R out 2, R out 1. Same thing. Okay. So let's go. Don't like the quizzes at the beginning, huh? That means I have to do that more often. Okay, so tell me what I want to have for my CAS Code. Oh, and intuitively tell me how I get higher output resistance. Somebody, you go for a job interview in analog circuit design, they say, well, okay, there's a CAS Code, sketch a schematic. Ooh, he did that a little too fast. How does it work? How do you get higher output resistance? What's the deal? What's the circuit technique? What are you doing that gets you the higher output resistance? No. By cascoding, how does cascoding increase the output resistance? Remember, it pins this voltage here at a fixed value in an effort to make the VGS constant and the VDS constant. Because if VGS is constant and VDS is constant, the current will be constant. Does everybody follow that? Very simple. Keep the VGS constant, keep the VDS constant, your current will be constant. Keep the ID current constant, keep the VGS constant, the VDS will be constant. Does everybody follow? Okay. Notice VGS always has to be there because that's the valve. That's how much you're turning the valve on.
In the previous, in the basic CAS Code, the bottom NMOS, it's not in saturation, correct?
No, it is.
It is?
Yeah, that's how come we have the VGS, it heads way into saturation. That's the problem.
The bottom one is,
Yeah.
even though VGS, it's the...
Yeah, yeah. Okay, so I want a wide swing CAS Code. Meaning I can go all the way to this voltage has to be greater than 2 VDS sat. If I don't connect this anywhere, it doesn't provide any current, right? I don't have the faucet on, I don't have any water going in my drain. Does everybody follow that? Okay, so what's the voltages I want? I want this to be VDS sat, and I want this to be VDS sat. And I know this one is just the same old VGS we're used to, right? Does everybody agree with that? But I want this voltage here to be now, think about it for a sec. What do I want this voltage to be? What is this voltage here? It's VGS. So tell me in simple terms and why, what do I want that voltage to be? I want this voltage to be VDS sat, right? This voltage is VGS, so what do I want that to be? Yeah, VGS plus VDS sat. And I derived that last time, and if all of these have W over L's, then to get this a little bit larger voltage, the VDS sat, I want this to be 1/4 W over L. But practically, I might make this 1/5, or in the nanometer process, even longer, okay? We derived this last time, and it's derived in the book. So this is the wide swing CAS Code. So now if I ask, what's the output resistance? There's nothing different. We just changed the bias so the DC would be alive. The derivation's exactly the same. Everybody follow that. So if I go look in the next section at biasing circuits, let's just look at that briefly before we talk about regulating the drain. And I look at this circuit. What is this circuit right here? This one. Beta multiplier. What's this part? Startup. This beta is multiplied up from this one. Any questions on that? Okay, so I go over here and notice I'm mirroring out the NMOS into this. And I look, all of my PMOS are 30 by 2, but I made this one 30 by 10, so it's 1/5 to move it a little bit further into saturation. So it's 1/5. What does this device do? It does the wide swing bias. So let's pause. Let's draw the equivalent of this schematic for the PMOS so we can go back and look at it. We go, oh, for the PMOS, I have the following. What does this do? What is this called? What's that? Current mirroring. It's just mirroring. I got VSG. I have VSG. It's a current mirror, PMOS current mirror. Anybody challenged by that? Would you say you were? By the way, I just asked it. Anybody challenged? Yes, I'm challenged. Okay. So I want this voltage to be what? Under worst case scenario. Easy because I just switched the S and the D and everything, and it's exactly the same. And ground and VDD. What do I want the minimum voltage here to be? What's this voltage? So I got a device here. What is this voltage? Now be careful because it's a little bit different. Now look at it. Here's my VDD. I drop down, I go down the stairs of VSD sat, then I drop down a VSG. So this voltage is VDD minus VS. It's the same thing for NMOS, except VDD is replaced with ground, which is 0, and then it would be VDSD. It would be VGS plus VDS sat, VSG plus VDS sat. Does everybody follow? So I make this guy 1/4 or 1/5 just to push it a little bit further out, so it's a little bit further away from the triode region. Does everybody follow? So in the schematic, I made it 1/5. So I go back to the schematic and I go, PMOS are 30 by 2. There's my beta multiplier going out. Goes to these two current sources. So that's a 30 by 10, or W over L times 1/5 to wide swing bias these. Wait a sec, how come he did this? What's up with that? Why did he do this instead of doing this? So let's talk about that. Man, it'd be hard for me to do a lecture without saying this and that.
Where would Vx be? Like where we have Vx, the V minimum in the NMOS?
This has to be less than or equal to VDD minus 2 VSD sat.
Okay. And then also in the NMOS, for the wide swing, so that's going to be 2 VDS sat, so it's a difference of, yeah, so plus V threshold, so it's a difference of V threshold bound as compared to the basic.
Yeah.
Right?
Yep, so this can go a threshold voltage lower.
So we enter saturation at the threshold voltage lower.
Yep. Okay, so now I'm going to go through how that minor modification, and you will all understand and go, oh, I understand that. We said a constant theme was VGS equal and VDS equal. So I'm going to try to make the VDSs of these guys the same. So let me show you how I'm going to do that. I'm going to take, and I'm going to have my same old device here with the 1/4. Let's go 1/5 just to be a little conservative. And I'm going to mirror that over here. So this is my output. And then I'm going to come up here and I'm going to add this extra device that really doesn't do anything except for try to equalize this voltage with the same as this one. Then I'm going to come up here and I'm going to diode connect like this. Now I'm going to write all the voltages. So the whole point of this device here is to make this VDS equal to this VDS, so this current mirrors this current more closely. Does it still work like this? If I got rid of that and just diode connected it, does it work? Yes. Just the matching of the currents. Now, you have all those sims. If you don't believe me, you can put it in and find out for yourself. Okay? Let's look. So what is this voltage? Okay, I'm going to ask you an easy question now. What is this voltage by design? Okay, what is this one? And then what is this one? Better be. That's the whole point of me putting that extra device in. So what is this voltage here? Now this is a little bit tricky. What is this voltage here? Yeah, it's VGS. Does everybody see it's wired? So this one we know is going to be in saturation because drain to source voltage is VDS sat. Okay? What about this one? Let's prove it's in saturation. Am I going too slow again? Eric? Are you sure? Is there a way to play the videos on halftime so I talk like this? So prove this guy's in saturation. So I'll write, for a device to be in saturation, VDS has to be greater than VGS minus V threshold in. Would everybody agree I can write that as V drain minus V source greater than or equal to VG minus VS minus V threshold in? Would everybody agree that's V drain minus or greater than or equal to V gate minus V threshold in? So what is V drain here? And what is V gate? Is this term? Is this valid? Is VDS sat going to be less than the threshold? Let's see, VGS is 1.4, 1.4, 0.6, 0.8. Let's see, this is from our quiz today, 1.4, 1.4, 0.6, 0.8. Does everybody agree with that? Any questions? Sure you don't want to meet this weekend and go through. What's your most important class? 420. What's your easiest one? 420. It's even easier than racquetball. Gotta have fun in life. All right. Because life is what happens while you're planning for tomorrow. All right. Let's see. That is 6. So I want to cover one more thing in the last 10 minutes. We getting our money's worth today?
I think the previous slides, you forgot VTH.
You're telling me I'm wrong? Is that what you're saying?
Yeah, 0, but it's not.
Where?
Yeah, VTH.
This one?
Yeah.
VGS,
That one
VGS.
was both, yes.
Okay, I could write that as 0.6 plus 0.8. So I just use the numbers from the quiz. 1.4 is the VGS, 0.6 is the VDS sat, 1.4 minus 0.8, and 0.8 is the threshold. It's in the book too if you think I'm wrong. Trust me, I'm from the government. Okay. So let's do one more topic. How do I get higher output impedance? I got to hold that drain voltage fixed. So here's what I'm going to do. I'm going to do the following for a circuit. So far, so good, right? Same old current mirror. How do I know? Because it's always controlled by the VGS here. How do I regulate this drain more? What I'm going to do is I'm going to put a transistor or an amplifier here with a gain of A. And then I'm going to put this at VDS sat. And this output, well, before we go any further, will be, well, let's just say what the output is. It's A times V plus minus V minus. Anybody not follow that? Anybody follow that? If you're in my lab and you don't follow that, you're gonna see some teardrops on my paper here. It's funny, we have 3 labs in op amps, 3 labs that cover op amps, and 4 people in my lab say that they're masters of op amps, and those were a waste of their time. 420L, isn't that what you told me? I'm going to quote you for the next 10 years. All right, so does everybody understand so first off, what is this voltage and why? That's right, VDS sat for high gain A. Why? Assume it's not. If I have a high gain A, then this feeds back. Let's say it's lower. Feeds back a lower voltage. Let's say it's ground. Feeds back a ground. I get what VDS sat, 600 millivolts, 200 millivolts, whatever it is, minus 0 times a big gain. That causes this to go way up. If it goes way up, it turns this device on until it pulls it up to the same value as that, roughly. Does everybody follow? Does anybody follow? Nobody follows, so let me do the following. Well, let me ask this. Does anybody, when you took op amps, did they teach you that you assume, for ideal op amps, you assume the 2 inputs are the same voltage? Can you explain that to somebody in Smith's? If you're standing in Smith's in the grocery line and somebody asks you, what is the voltage there? Can you explain why they go to the same value? No, you can't. Don't lie. All right, so you can. You better. You're in my lab. Let's say I have the following. Let's say A equals infinity, or something really big. Let's say this is 1K, 1K, and this is 0 and 0. The op amp says, hey, I got infinity times 1 minus 0, because it's always going to be whatever the open loop gain is times the voltage on the positive node times the minus node. Everybody follow? Well, that's going to be what? What's the output of the op amp do? It's going to go up. And it's going to keep going up, which causes this voltage to do what? To go up. Until this output hits 2 volts, and then there's a voltage divider, and what's the voltage here? 1K, 1K, 2 volts, so it goes to 1 volt. Does everybody follow that? Well, wait a sec. If it goes to 1 volt and 1 volt, I get infinity times 1 minus 1, which is 0 times infinity, which is about, oh, now I know why the 2 inputs always go to the same voltage. Because if they don't, the op amp feedback action forces them to the same voltage. Everybody follow that? So it's not magic, it's just with the feedback action and very, very high gain, they got to be very close to each other. Yay or nay? Okay, so let's go back up here. Does everybody understand that if I put a VDS sat here and I have a big gain, this is going to go to VDS sat as well? Because if it's a ground, this is going to go up until the MOSFET turns on and drives this to VDS sat, and those two voltages are equal. Questions? Okay, so I'm going to kick it into high gear because we only got 3 minutes, and you know how I like staying late. What's that AC voltage? Does everybody agree? What's this AC voltage? It's a bias voltage. What's the AC voltage? 0. What is the VGS here? What is the VGS? It's the exact same problem. 0. So I replace this with the device R out N. What's the current that flows when I apply my test voltage, knowing I got to bias it up? I test times R out N. So this voltage is I test times R out N. What is V plus equal to, AC? What is V minus? We're just repeating ourselves. What is V minus equal to? So what is this voltage here equal to? So I'm going to go sketch this on the next page. Any questions? So what is VG2 equal to? Why does he keep asking simple questions? I keep trying to make it hard, and it's not hard. So here's a hard one. What's VGS2 equal to? Oh, whoops. Yeah, it's going to be minus ITRON times 1 plus A. You know what? Time's up. Let's do this problem again when I can do it slower at the beginning of next lecture. Do me a favor and read everything in Chapter 20, especially the biasing circuits, because we're going to use those throughout the rest of the semester. I want you to understand, and if you have questions, I want you to be able to ask them. Will we have a quiz on Tuesday? Probably, because I'm told those are good learning experiences. But maybe not. Maybe I'll get lazy. Have a good weekend. We'll see you on Tuesday.